Okay, I guess we're back. I mean, I have no idea what that is. My internet was fine that entire time. Let me go delete whatever the heck post it just made. 2 minutes. More. Delete. It's fine. We'll see if it's stable. Man, that's ridiculous. The internet here is just like that shitty. Alright, well, stream looks like it's okay. Welcome back, folks. There's not much I can do about it at the moment. I have no idea why it happens. It always happens from this house as well. Like, the internet's completely fine, but Restream just drops. I have no idea why. Well, let's keep going on this for a bit. I might just get, like, I'm only here for a week, but probably the next time I'm here, I'll just get, like, Starlink or whatever, because apparently Florida infrastructure just doesn't work. I don't freaking know. I wouldn't think it could even be something with Restream, maybe. The internet's definitely been spotty here too, though, so. It's weird that it happens even when I see that, like, it seems stable, though. I don't know. Isn't this, like, a pretty sizable drone? This should look bigger than this, no? Okay, that's, like, tiny drone. But, like, 0.75. Yeah, no, it should be bigger than that. 7.75 radius is quite large. Okay, so they have the sphere. Oh no, this is right. This is r over 2. Then this is plus r minus r. That seems right to me, but it's not. This thing should be substantially bigger than this, I would think. Well, maybe not. Okay, but then the ring should be, ring radius should only be 2 times the arm length, 4 times the arm length. This. Okay. So now I should be able to do, yeah, so that's a big drone, right? So we're going to want to do, let's say, the scale of things that we want to look at is going to be everything from like 0.05 or something, 5 centimeters, up to maybe a couple of feet initially. So nowhere near this big. So let's do like this. Let's see what this does. You're not going to be able to see this is the thing. It's like this little tiny point down here. Can you actually control this, I wonder? Let's train this. And then afterwards, what we'll do is we'll see if we can randomize the size and learn over different sizes. Interesting. So this does not work. Let's see if we can make the rings bigger. Oops. We can also randomize the target size. Yeah, this is not training at all though, which is a little odd. Okay. Let's go back to like what, 0.1? Or I think 0.2 was our original. Okay, this is annoying. We're actually still not learning. These were mostly rendering changes, weren't they? It can fly around and not crash, but it can't figure out how to get in the rings. Okay, so now it's actually doing something. It is having a tough time though. Okay, so what did I break in the process of doing this? Yeah, I totally broke something. Yeah, you can see here it's not working. Is the policy observing from first person or 3D person camera? Neither. It's just getting its relative state-based estimate. So when we throw this on real hardware, we're just going to have to do some like really basic perception, not even end to end, to just figure out where the rings are, or to like figure out where the target is. You ideally don't really want to do end to end camera if you can avoid it for quite a while. You just make everything between 100 and 1,000 times slower. We can absolutely do stuff like, put the ring on like the ring position only if it's in the vision cone or something. That's easy. Okay, what did I mess up here? The rings look smaller than before. Yeah, they're definitely smaller than before, right? Yeah, so this is how it worked before. Okay, now it trains. It needs really big rings. We were doing 0.1 before. No, we were doing 0.2 before. So we'll go 0.8. So times 4 in either direction, I suppose. And then we'll do like this. We'll give it a small amount of domain randomization. Cool. So if we can get something sort of similar to this to train, then this is something I can show to Finn and Sam. And we can check the formulas. Hey, Kirthi. Yeah, I'm in Florida for a little bit, and then I'll be in California thereafter. So we're kind of making do on a laptop setup for now. And if the internet is not amazing, OBS likes to crash every so often, but we're making do. Okay, so like this does train, and it is fairly stable. I don't know what the best you can get us out of this, but let's see what the policy looks like that does this. What are you cooking? So we're trying to make the same RL able to fly a ton of different types of drones. Now they're hard to see because like we're now working on really, really small ones. But I'm trying to randomize like the physics, randomize the drone parameters, and get it to be able to fly pretty much any different drone. So this is a big drone right here. You can see that the control is not exactly reasonable. And that's not because of the physics of this thing, it's just because I've scaled everything wrong. Yeah, so the ones that like shoot around like crazy are not going to be super learnable, yeah. All right, let's see if we can figure out from the math what I've done wrong here. It's all here, right? So it's just the scaling is somehow screwy. Folks are, you can feel free to tell me if I've screwed up physics, if you know this type of stuff. So the mass is going to scale cubic with the size. That seems fine. Plus or minus 10%. Then you got the inertia scale, which is mass times arm length times arm length. That also can be plus or minus 10%. Thrust. Why is thrust proportional to mass? K thrust. It's probably the RPM being scaled weird, no? We'll see how this trains by comparison. $75 follows away from releasing the new RL guide. I will have to make the images for that later. Okay, this did not help. Presumably the drones are like falling out of the sky or something because they're not able to keep themselves up. Let's watch it a little bit. So these are the tiny ones. The tiny ones are kind of fine. They zip around. They've got quite a bit of they don't handle super well. Yeah, I don't know what that's trying to do. Oh wait, did I mess up the Z inertia? I think I messed up the Z inertia, didn't I? Let's try this. Oh, actually, I don't know if it's Y or Z. Yeah, hang on. Yeah, it's Z. Okay. So if we fix that weird inertia scale, it does train. This is worse than before by a lot, isn't it? Well, I guess we'll see how it converges. So far, very bad. Oh, because it's not proportional to mass. Hang on. Okay, so it does get to like 60-ish%. And then let's make this proportional to mass correctly. And then after this, what we can do let's get this, put this into Grok. Use Grok 4. Up, and computers crashed. Lovely. Oh, are we alive? I guess we're alive. I have 16 gigs of RAM. This should be allowed. Like this should be fine. Hmm. How are you liking Grok 4 so far? Um, it's like the same problem with all the models, right? It's slow. It's like very slow. So I've mostly just still been using Grok 3. Yeah, it's really slow, right? And like I asked something fairly basic. Mass is distributed radially. Okay. Scale is L to the 5th. Fine. That was a dumb thing to do anyways. Oops. And there goes the computer again. Yeah, it's completely locked up for some reason. Am I out of memory or something? What the hell? No, I'm not. That's just Linux being Linux, I guess. I have no idea. Just randomly locks up and sometimes it comes back, sometimes it doesn't. This is just Ubuntu. I'm not even doing anything weird. Do you know what Isaac Lab is? Yeah. We've done contract work in Isaac Gym, even though that's old. We wouldn't need Isaac Lab for something like this. It's just going to be slower than what we're doing here and 10 times the amount of code. thruster weight decreases as 1 over L. Interesting. Would you recommend Isaac Lab for vision-based RL? No, not at all. Um, like, if I had to do vision for this, I would still keep the logic. I would keep the logic like I have it here, and then I would hook it up to the batch renderer of any of these engines, but I wouldn't use the engine itself. Like, I think Madrona has a decent, more almost standalone batch renderer. I'd probably just try to get like a standalone batch renderer, if that makes sense. Like, all the main physics engines are just really bloated and slow, and you have no idea what they're doing half the time. They're just slow and like screw you if you want to figure out why. This is just like layers and layers and layers of stuff. We do I over L. We keep it as I. Quadratic with area. Scale is L squared. We can do this. Max RPM decreases. I think that this is going to be like not make it able to fly, but we'll figure that out. Okay, this is closer to the original dynamics. Now if I say that the drone is going to be substantially bigger, yeah, that's not it. I have no idea what that is, but that ain't it. Mass scale is fine. There's K drag and B drag, right? Drag torque coefficient, linear torque coefficient. I don't think we're using RPM scale. Oh, well, this is backwards. Yeah, that's backwards, so that'll do it. Okay, but now it can't fly. No, it can. It's just very bad at flying. Let's see if we can train something on this. And then what I'm going to do is I'm going to move this to a not broken version. I'll commit this and I'll chat with Finn and Sam on like how we can get this to into their stuff. Like we'll just give them like a little bit of domain randomization and a very like even just give them a little bit of domain randomization will be fine. This says it's learning. Maybe it was just a control problem. It's learning. We'll see if this crashes the laptop again. Hopefully not. Okay, 97%. So yeah, look at that. This is a pretty dang good approximation to like a big slow drone, right? It's a good approximation. That's not bad. Let's try Zippy drone. What do we think? So the smallest drone we would ever do is like this, probably, right? Train this, see if it works. So if this trains, if we get this to train, then that means that we can train whatever we want. And we can train all of them. And this seems like it works. Yeah, this seems like it works very well. There we are. I didn't expect it to get this fully working in just like a few hours. But I think we have it. Episode length 200. Yeah, this is going to be a crazy zippy drone. Oh yeah, that's zippy drone, right? Look at that zippy drone. Cool. Now, here's the question. Both of these work, right? All these actually work. These are all of our, both of our configs. So can we get this to work? Which is going to be the randomized one. From 0.05 to 0.08. If this works, this will be the equivalent of flying any drone from like this big up to about like this big. So pretty much all commercial drones, like except like the ridiculously big ones, which we can do that as well. We'd have to make the course bigger because they don't fit through the rings. It is training. Understandably, when you add domain randomization, it depends on if your problem is sparse or not. If your problem is dense, typically it will take longer to train. If your problem is sparse, it can actually be faster to train. This is a dense problem, so we would expect that this is going to take longer to train. I just want to see if we can get some reasonable perf out of this to start. Okay, so like 90% with just a minute of training with the same like tiny little network is fine. 87. That's still a good result though. I mean, I think you'll see when we eval this. I would think that this one should be faster. It might just be controlling it very conservatively because it doesn't want to like screw up with the bigger drones. Hey, Bet. Is this the Secretary of Defense that you've just linked to me? Oh, yeah. Yeah, kind of a good time to be in this space. I'm sure they have no idea about any of this. This is controlling any drone. Like this is a much bigger drone. I mean, that to be fair, they can probably figure out how to hire a bunch of people to pilot them manually. But yeah, the autonomous one's harder. Oh, you know why this is slow? Because I messed with the FPS. This should be identical to before. We don't have to retrain. We can just eval this. Only not in autonomous tech is mandatory. I mean, realistically, either of them is going to be a step up, but yeah. Like, it's a pretty massive difference. Okay, this is way better. So now we actually have something that looks reasonable, right? Look, we've got Zippy small drone. This is Zippy small drone. We've got like reasonably slower big drone. Perfect. I mean, this is exactly what we wanted. This is fly whatever drone. Let's commit this all up. Okay, I will push that up off stream in a second. Well, yeah, but anyways, where are Finn and Sam? Where are Finn and Sam? Let me actually I know what I can do with this real quick. It's just real quick here. Just gotta do this off screen. Okay, that's pushed. So that is live. Y'all can play with that. Plus 26. What's plus 26? Oh, this. Yeah, so we are depending on how this goes, like in the next couple of days I should be launching the guide for 10K, which will be pretty cool. Yeah, well, get me to 10K follows and you'll have the guide. It makes sense to do it. It was like a decent amount of work. It makes sense to do it for the 10K milestone. Right. Let me get this onto the bigger machine. That's what we'll do because I have to go to dinner early today. So let's just go get the. It says I'm Puffer Outreach on the website. Is that what it says? That's mostly what Spencer's been doing. I think it says you're the Puffer proselyte. No, it doesn't. Where does it say that? I did? Am I blind? Oh, outreach. Yeah, you're right. Okay. Whatever. Sure. We appreciate the outreach. That was outreach before we were doing actual client outreach, but yeah, sure. Offers open for you as well if you want to try to get onto the contract side of things. It's mainly just about whoever can help us find actual clients for things that they can actually be a part of. I mean, you have skills in other areas, right? I don't know if there's anything you can do on that sim side. Maybe. Yeah, let's just real quick, here's what we'll do. Do I not have tail scale? I don't think I have tail scale on this machine. That was a dumb thing not to check that I had. Chess coming along. Yeah, the guy, what was the other guy on Twitter? He said he was interested in helping with that. I would very much like to have like a good working chess. He said DeepMind got it to work reasonably well internally, so if we had an open source of that, it would be really awesome. All right. Yeah, like now that I think about it, Bet, you could totally, you don't even really need to do a search baseline, like at all if you don't want to. You can pretty much just use Stockfish for eval. I do think though that like literally, well, just making random moves probably doesn't get you very far. I don't know. I'd be kind of interested to know what elo it would be if you just make random valid moves, but you never blunder a piece. I wonder what elo that is. Welcome, Jai. No CUDA GPUs available. Lovely. Don't you love Docker? Search is going to play into things. Like, you kind of get the idea, though, right, Bet? Like, we just want to see how good of a chess thing we can train very, very quickly to, like, a reasonably good elo. My 5-year-old can beat pure random that doesn't blunder pieces? I highly doubt that. Oh, pure random, yeah, of course. If you never blunder a piece, I think that you actually already get to, like, a elo that is above a brand new human player, right? Because humans are like, you're not making random moves, but people blunder pieces even in long form chess up to like what 1500 or something, like commonly. More, yeah. It's kind of amusing how bad I am at like, I'm bad at like almost all games of that form. Like I'm bad at all puzzles. I'm bad at like all search-based games, pretty much. Hmm. Okay, this train's at 3.7 millisteps per second, so that's nice. Let's say we show people the Neptune graphs. I actually have no idea how hard chess is bet. Like, what elo is exact two-step search, like two-step look ahead, right? That's like a fun question to ask for a lot of these problems, right? What elo do you get by doing exact, like one step, two step, three step look ahead? Okay, so we trained for 500 mil, we got 95% perf. And it's still going up, right? Yeah, this is still going up. So I think that if we literally just screw it, billion. Billion steps is chump change in Pufferland. Yeah, so this is interesting. It's actually not even near the previous performance. Oh, it's unstable. Huh. Well, folks, what do we do when our neural net is unstable for when you do longer runs? Time's up. Correct answer is lower the learning rate. Sweep is the Nuka fly with a, Nuka fly option. If it's a quick problem, you try just cutting the learning rate in like half first. We will probably run a sweep anyways on the machine. Huh. It doesn't seem like it learns at all with lower learning rate. Isn't that funny? That's something. See, this is why hyperparams make absolutely no sense. Try this one more time. Yeah, absolutely, right? If even I can't like consistently make good predictions about hypers after all these years, it just doesn't follow any sort of sense at all. Here, we'll see if this does it. And then we'll just run sweep on this box. It shouldn't, it at least should not be hardware dependent. The sweep is hardware dependent. The sweeps are hardware dependent because we base them on we base them on train time in seconds. You were doing physics stuff. Was it coherent? Kind of. It was very basic physics and it was very slow, is the thing. Amusingly, the first set of hypers I set was the best so far. There was like a takeoff point, you know? You see how in this original graph it kind of dipped up at the top or at the end? It was interesting. This is stable? Not really though, like it's not stable would be like a log linear curve. I'm gonna try one other thing manually, and then I'll just like run a sweep or whatever. No, see, it's like it's not. It kind of learned everything, and it's kind of just leveled. Yeah, let's just do here. This is what we'll do. We'll go 500 mil, and we'll do policy or hidden. RNN. Size. Give it a little extra capacity. Oh yeah, it likes that. Okay. What the hell are you doing? Let me show you. We have this drone simulator. Welcome, Aditya. We've got this drone simulator, and we're doing reinforcement learning to control the drone. And since we want this to run on real hardware, I am adding a bunch of noising techniques to the sim that should make the policy that we train on this way more robust in the real world. So basically, we're training to control all sorts of different types of drones under a whole bunch of different perturbations. Oh yeah, we also have multi-agent stuff. Let me see if I can find the demo that I did for that. We had a 4th of July Day demo on this. Yeah. You can train a whole bunch of them to like arrange themselves into a flag. And they like bump each other out of the way because they try not to collide. This is a pretty fun graphic. Yeah, you see they like bump each other out of the way. They try not to collide, so they move out of the way of each other as much as they can. It's at 94, 95, it looks like. Well, that's an interesting graph. So it ended up in the exact same spot, but just with a different, like, a weirdly different curve. You see this? You did your bachelor's in computer science AI, same thing. I was already doing reinforcement learning, like, after sophomore year, I was doing RL. I was doing natural language processing and machine learning before, like, natural language processing and computer vision before that. Okay, well, we don't need to make the policy larger for the sake of making the policy larger. So we'll just use like tiny environment. And I think we need downsample, right? Yeah, downsample like this. Right. Do these things have a score metric associated with them? I did make a score, right? Did I not add score? Oh, no, there is a score. We're fine. And the learning rate is true. I don't see anything bad in here. Currently doing my bachelor's in CS second year. Can you give me suggestions on what I should do? I mean, it depends. That depends entirely on your goals, right, man? It depends entirely on your goals. Oh yeah, I forgot time steps. I don't want to do a master's. Yeah, but like, what do you want to do? Right? Computer science is very broad. Emailing to apply to things will only work if you know what you're doing. That does work, but it only works if you know what you're doing, and then you like can very quickly and obviously prove that. Can you suggest some topics that are novel in the field right now? In RL, absolutely. In fact, I have there's a guide that I'm releasing very soon. As soon as I hit 10K followers on X, we're like 75 away. That has like a full overview of a lot of the things I'm thinking about. I think that the main thing that I'm interested in research-wise at the moment is figuring out what the heck was going on with all of the like sample efficient RL stuff that DeepMind was trying to do and have been doing for many years. They're kind of like there's a huge amount of stuff in off policy, model based, search. These are all sort of methods for how do we use more compute to reduce dependence on having tons of samples. But the thing is, like, the quality of a lot of the research out there is very, very low. And even the research that's done very competently, there are just a huge number of conflating variables that make it very difficult to isolate the causes of anything. So figuring that out properly is really a major thing at the moment. I think in research in general, like, that's kind of the broad topic, right? The sub areas of that are off policy, model based, and search. There's a whole bunch of cool stuff we can do in multi-agent learning and adversarial stuff that we can do now that we weren't able to do before, that we could do very easily in Puffer. There's still stuff in RL Infra to be solved. There's still stuff in like why do architectures not scale up appropriately. I mean, really, they're quite a large number of different things that we still need to do. At the very least, though, I mean, here's what you can think about. This is probably the best way to put it. Like, a lot of the research that was done in 2017 to 2024 era was kind of just doomed to fail based on how slow everything was. But now we're actually positioned to do stuff fast, and that makes a huge difference on its own. And yes, do star the puffer and all that stuff. It helps me out a ton. It's free. This is all open source, yes. Joseph just starts talking and you're busy for 2 months. Well, I mean, it's a whole field, right? Like, yeah, congratulations. I've been busy for a decade. I take breaks. Of course, it's a skill issue. Like the stuff, just it takes time to learn. What the heck is wrong with my Vim? Holy. I have no idea why you can't. Why that's doing that. That's bizarre. I'll use the other term. Redev streams live. I like it. Oops. Hey, welcome. Hang on, I messed everything up. Alright, here, we'll do this. Welcome, Rajat. Rajat. Welcome. Fixing RL one line at a time. I mean, that is an app description. Oh yeah, we don't need this Docker actually. We just need. What if I just do this? We just make the policy gigantic by RL standards. What am I doing? I'm doing reinforcement learning research and applications. A bit of both. Hey Joseph, do you think Pufferlib can make it possible to train graph neural nets with reinforcement learning given constantly changing input and output sizes of those nets? Currently getting into, if the R is recurrent, then a recurrent graph. Wait, recurrent, is that a recurrent graph convolutional net? I don't know the acronym for that. Relational graph, okay. So I don't know, are those things fast? That's my main question. Like, has anybody actually done the math and like, how fast does one of those run compared to a like a standard architecture of the same size? I've never gotten into GraphNet. It seems like those could probably. I don't even know if those can be made fast, to be fair. The closest thing I've gotten into that is I've done neural module networks, which is like it's a graph or realistically like a tree or a DAG. And that's, I think, like a DAG, yeah. And it's made out of each node in the graph is a small neural net. I've done that before. Okay, so this actually works just fine. See if this runs. Regarding the guides you mentioned, could you talk a bit more about the content it's going to cover? So if you check either X or the Puffer website, there's a quick start guide that has a lot of good general advice for how to view reinforcement learning and what to do and like resources to look at. The guide I'm releasing is a much more extensive and much more formalized version of that has a way better like step-by-step, implement this, read this, implement that, read that, like step-by-step to how to learn reinforcement learning that references my quick start guide. There's also like a general ML and programming advice guide that I've put together. It'll reference that. It references other articles that I've written. It references stuff not by me. It references like several blog posts and a bunch of academic papers. So it really gives you like a way more comprehensive overview for everything. Okay, so I figured I'd just put this, I just increased the size of the network for Neural MMO3 just so we had like something running on this box, because you never know, maybe it does something cool for us. There are ends where most of the data is best represented in terms of entities and their relations. Yeah, that's pretty common. Cabinets are a natural fit. Think of Stellaris. Okay. Read the Entity Neural Nets blog post from Clemens Winter. Clemens? Yeah, Clemens Winter. Buddy of mine. I don't think you need full graph nets, basically. You do probably need some sort of transformer or some sort of attention. Attention in reinforcement learning is really obnoxious, though. Like, even small transformers or even small, like, single layer attention things are very slow. But that's going to be your best reference. What article was it? Entity Neural Networks. Hope you get 10K soon. Yeah, thanks. I mean, we're almost there as is. We're like very, very close, which is why I made it a 10K goal instead of just posting it. Because I figured like, okay, we'll get there in a few days anyway, so it would be like a cool thing. It's like 75 away, if that. All right, here. So yeah, this will run. What I just set up for this, I set up a hyperparameter sweep with protein, which is our hyperparameter sweep algorithm. It's a very nice algorithm. So this is going to run 200 experiments of between 100 million and a billion steps each. And this will be done in some number of hours. And hopefully it'll find for us a good set of hyperparams for this. And if it doesn't get above 0.95, then I'm going to suspect that there is, like, basically that some combinations of the randomizations make the env unsolvable. Because normally our RL is ridiculously good, so it kind of just solves everything. Like, more often than not, when it doesn't solve, there's a problem with the environment at this point. Time is it 5:20? Yeah, so I'm in Florida today, and well, for the next little bit. I don't have anywhere near as convenient of a setup as I have in Maryland here in Florida. So jank stream setup, occasional disconnects with OBS, but also I have to spend longer on things like food. Anyways, the plan for the next couple of weeks here, I'm spending a little time in Florida, then I'm going to California. I'll get myself set up properly as best I can in California. I'm going to be taking a whole bunch of meetings while I'm there, so the stream is going to be a lot less consistent for a little bit. But I will be at RLC in person. So if you want to come say hi and you happen to be going to that, let's meet up at RLC. I believe Spencer's going as well, which will be fun. I'll be presenting Pufferlib there. Technically, it's the Pufferlib 2.0 publication, but I will make the poster for 3.0 because it would be silly to not update it. And yeah, I'm mostly just going to be looking to hang out there and chat with a whole bunch of people doing a whole bunch of different things in RL. Yeah, I'm not looking forward to having to make that poster bet. It's a bit annoying. I'll probably go look at like one of the old posters and see what I can steal from that. The old Puffer posters that I made before. I already have business cards. I'm not updating those just for this conference. Not happening. Hello, Imanshu. I'm about to head out for the day. Actually, real quick, since we do have, well, we do have some people. Cool. Today we got drones working, randomized very nicely. 95% accuracy at least. We'll see if we get 99 overnight. If you are interested in all this stuff, everything that you see me developing is free, it's open source. Most of the people that help on this just randomly showed up one day and started contributing. So if you're interested in that, everything's at puffer.ai. You can start the repo to help me out for free. Join us on Discord to get involved. And you can follow me on X for more content. I put a lot of the articles on the blog here, but not all of them. So there is unique content on here, and it's all RL based. It's like I pretty much only post RL stuff. So yeah, thank you, and I will be back probably tomorrow morning doing likely more drone stuff. Is going to be the guest, depending on if Finn and Sam see this, and we can chat about some of the physics.